Good afternoon and welcome to the lecture 16 of ETC 779. Today we are going to cover replacement analysis. In whatever lecture we have had till now, you must have noticed that we were more concerned about acquiring a particular asset. So, all our previous discussions focused on acquisition of assets. Another very important question that an engineer has to answer is when to replace an existing asset. So, there are two set of assets, one which is already existing with us, those we will be calling as defender, and then there will be another set of asset which we call as challenger. So, there are two terminologies which we will be learning in this particular lecture. One is called defender, another one is called challenger. You must have noticed that some equipments after some point of time, they do not give you same efficiency as you would have expected them to give you. Also, the cost of operating them becomes higher. So, there is a point in the life of a particular asset when you find that the operating cost and other costs put together is at minimum value. Now, beyond that point of time, you will find that costs start increasing. So, we are basically concerned about finding the exact time period at which we should replace our existing asset. The asset could be some kind of equipment such as let us say diesel generator set, or it could be an excavator, or it could be a batching plant, or it could be something else, tunneling equipment. So, our primary focus in this particular lecture would be to make you aware of the tools that are existing which will enable you to take decisions regarding replacement of a particular asset. Now, in this connection, we will be learning certain terminologies which are exclusively used in this kind of analysis. Two terminologies I just now expressed, one is called challenger, another one is called defender. So, a typical problem in replacement analysis would be to find out when exactly challenger should replace the defender. So, this is what the focus of current lecture is. Now, if you look at this particular slide, you will find that this is one of the most important questions that is asked frequently in the industry. Of course, the first question is how to evaluate different options as far as acquisition of assets is concerned. Prior to this lecture, in all our discussions, we had focused mainly on acquisition part, how to acquire new assets. If I have got different alternatives, which one to choose for, and for that we learned different methods, present worth method of analysis, future worth, annual cost method, incremental rate of return method, and then for public projects we learned benefit cost ratio method of analysis. If you are working at sites, or if you are likely to work at site, you will find that you frequently come across a question like this. For example, when should a new asset such as let us say diesel generator set replace the existing diesel generator, or when should a batching plant replace a new when should a new batching plant replace the existing batching plant. Many such questions you would be posed if you start working at sites. Similarly, if you are dealing with civil engineering projects, one of the important questions would be when should a form material is basically your formwork material, should be replaced, after how many repetitions, whether it is after 10 repetitions, whether after 12 or 15. So, such questions normally we face during our day-to-day working at project sites. Similarly, one of the other questions could be is it worthwhile to continue with the same scaffolding material, or is it time to replace it with new scaffolding material? So, for these kind of situations, replacement analysis provides us a tool through which we will be able to know when exactly a particular asset should be replaced with the new one. The new one we call it as a challenger, and the existing asset we call it as defender. So, the next question that you would like to know is that you would like to answer is, why basically we are trying to replace our asset? This is because of a number of reasons. The assets can be replaced because the current asset might have become obsolete. There must be some technological changes. For example, if you just see your current day-to-day changes in computer industry, you will find that processors are changing very frequently. So, initially we must have been working with P1, now we have P4, and even the advanced versions are coming up every day. So, because technology is changing, if our equipments are not keeping pace with the existing technology, you will find that we are not able to work efficiently, we are not able to work economically. So, this is one of the important reasons why we need to replace the asset, because assets go on getting obsolete after the passage of time. Then there could be loss of market value. For that reason, you want to acquire new equipment, new asset. Similarly, your equipment must be undergoing deteriorations of different type, wear and tear. So, its efficiency may not be as per your liking, and that is why you want to replace it with new asset. Then there could be physical or mechanical impairment. Then finally, the maintenance and operation cost will go on increasing over the passage of time. So, it may not be worthwhile to continue with the same set of equipment, and that is why you tend to go for new set of assets. Then sometimes the existing equipment which you are using may be inadequate, because your requirement might have changed, and so the existing equipment which you are having may not be able to may not be in a position to fully cater to the desired function. So, that comes under inadequacy. So, these are some of the reasons why people go for replacement of existing equipment or existing asset with the new ones. Now, the question before us is therefore, should the defender be replaced now, or should it be kept for one or more period? So, every year we want to perform this calculation, so that we know where we stand. Is the cost of carrying on with defender is less than the challenger, or is it more? And depending on these values, we may take appropriate decisions. So, this is the objective of performing replacement analysis. When is the time to replace the existing asset with the new asset? Now, if you see the definition part of it, already we have defined. Basically, defender we are calling them as those existing equipment or asset which is already in place. We have already implemented these. So, they are called defender. Suppose we have a diesel generator set, or we have a batching plant of, let us say, 100 cubic meter per hour capacity, right. So, this is already in place. So, this we define it as defender. Defender is one who is resisting the imposition of challenger over it. Now, what is challenger? Challenger is the proposed replacement which is currently under consideration. Say you might have a batching plant which is of 150 cubic meter per hour capacity. So, that we can term it as a challenger, right. Now, here one more thing we have to understand while performing replacement analysis. Replacement analysis is always performed from a third party angle. Now, what is this third party angle? For this, I will give you some example. Let us assume that a particular piece of equipment was purchased 4 years ago at some price, maybe rupees 100,000. Now, its current market value is, let us say, rupees 20,000. So, in all the analysis, we will be taking rupees 20,000 only. What about the difference of 100,000 minus 20,000? That we are calling it as a sunk cost. If you see this slide, I have defined this. So, let us say a particular piece of equipment was purchased at some price P0 some time back. Now, its current market price, let us assume it to be P. So, the difference of P0 and P, we are calling them as sunk cost. Now, in the analysis, in replacement analysis, we are not concerned about this sunk cost. So, P0 minus P, we will forget about it. This is the basic concept behind performing replacement analysis, because it will be unfair for the challenger if you are considering this P0 minus P value. That is why we call this as a third party view. For a third party which is neutral, who is neither favoring challenger nor favoring defender, for him the price at which you bought the equipment some time back is of no use to him. That is why he is more concerned about the current market value of the existing price, P. He is more concerned about P rather than P0 minus P. So, that is why in all our analysis, we will simply neglect the sunk cost, that is P0 minus P. Now, we will try to illustrate you with the help of an example. You can note down this example. In this particular problem, I have assumed that an equipment which was purchased at a cost of rupees 22,000 4 years ago, now it is considered for replacement against a challenger whose cost is rupees 18,000. So, what does this mean? Some equipment I bought at rupees 22,000 4 years back, right? Now, some new equipment of similar type has come, which is costing me 18,000 rupees. Now, the existing equipment which I bought at 22,000 can be traded in today at rupees 6,000. That means, its current market value is how much? Rupees 6,000. And if it is kept on for another 6 years, it will have a salvage value of rupees 2,000. The annual maintenance cost of the existing asset is rupees 7,000 per year. For challenger, the annual operating cost is rupees 3,500 and its salvage value is rupees 3,000 at the end of year 6. Now, what we have to do in this problem is, we have to advise whether it is time for replacement or not. So, if you just try to do this example with the basic cash flow diagram, it would be easier for you. So, what you do? You draw the cash flow diagram for defender separately and for challenger separately. It will become very easy for you to take a decision once you are clear about the cash flow diagrams for the two cases. I will illustrate you how it is done. So, let us say I am drawing it for Defender first. Defender is what? The existing equipment. Let us see, let us make it 0 time t is equal to 0. Now, the equipment was purchased 4 years back. So, minus 1, minus 2, minus 3 and minus 4. This equipment was purchased for how much? 22,000. I purchased this equipment for 22,000 4 years back. Now, this equipment is going to last for another 6 years from now. So, you have 1, 2, 3, 4, 5 and 6. Every year I am spending how much towards its operation and maintenance? Rupees 7,000. So, 7,000, 7,000, 7,000, 7,000 here also and here also. What is the salvage value that we will be getting at the end of year 6? 2,000 rupees. So, this I will put it in positive side, 2,000. What is the current market price of this existing equipment? 6,000. So, this I will put it at this point, 6,000. Now, this is as far as cash flow diagram for Defender is concerned. What about the Challenger? Challenger I can buy it at rupees 18,000 at time t is equal to 0. What is its operating cost? 3,500. Year 1, 2, 3, 4, 5 and finally 6. Every year 3,500. And what is the salvage value I am expecting? Rupees 3,000. Now, as far as this replacement analysis is concerned, we will have to forget what value? 22,000 minus 6,000. That we are calling it as a sunk cost. So, sunk cost in this case becomes 22,000 minus 6,000, which is equal to 16,000. Now, this 16,000 value we will not be considering anywhere in our analysis, because it will be unfair for the Challenger if we are taking this value into our consideration. So, we will be more concerned about this 6,000, that is the market value of the existing equipment at time t is equal to 0. Now, once I am able to draw these cash flow diagram for Defender as well as for Challenger, taking an appropriate decision becomes very simple. What I will do? I can follow any of the methodologies that I have discussed already. However, for such cases, it is always better to go for annual cost method. So, we will calculate the equivalent annual cost for both the Defender as well as for Challenger, and whichever cost is coming to be less, we will go for that option. So, how to calculate the equivalent annual cost for Defender as well as for Challenger? For, I will say, equivalent annual cost EAC, which is equivalent annual cost for Defender EAC, it would be equal to how much? 6,000 multiplied by A given P, because this is the money that I will be getting if I am selling it right now in the market. Interest rate is given to be how much? 15% for a period of 6 years, plus the maintenance cost, which is equal to 7,000 minus the salvage value, which would be equal to 2,000 multiplied by A given F at 15% interest rate for a period of 6 years. So, if you calculate it like this, you will get a value of 8356.80. So, this is as far as Defender's annual cost is concerned. Now, following the similar process, we can calculate the equivalent annual cost for Challenger. So, what would be the EAC for Challenger? For Challenger would be equal to 18,000 multiplied by A given P at an interest rate of 15% for a period 6 years, plus 3,500, which is nothing but the operation and maintenance cost minus the salvage value, 3,000 multiplied by A given F for a period 6 and an interest rate of 6 years, 15%. Now, this will be equal to 7,913 rupees 7,913. So, what we find here is that if I continue to use the Defender, I am having a cost liability of rupees 8,356 and 80 paise, whereas if I go for the Challenger, my equivalent annual cost liability is only 7,913. Now, since the equivalent annual cost of Challenger is less compared to the Defender, we would recommend the adoption of Challenger. Is it clear, technology class? Yes. Okay. We take another example in similar line and then it will be more clear. Just note down this problem. It says 2 years ago an equipment was purchased at a cost of rupees 200,000 to be useful for 8 years. Its salvage value at the end of its life is rupees 25,000. Annual maintenance cost is rupees 25,000. The market value of existing equipment is rupees 120,000. Now, a new equipment is available at rupees 150,000 to be useful for 6 years. Its annual maintenance cost is rupees 14,000. The salvage value of the new equipment is rupees 20,000. If the interest rate is 12%, find if it is worth replacing the existing equipment with the new equipment. So, this problem is very similar to the previous problem that we solved just now. Here again you have information for Challenger as well as for Defender. Defender equipment you purchased for 200,000 2 years ago. Now, it is useful for another 6 years, and at the end of its life you can sell it at 25,000. If you are operating this equipment, your annual cost is 25,000 again, and the market value of this existing equipment is rupees 120,000. Now, a new equipment which is the Challenger is available for rupees 150,000. It is again useful for 6 years. However, its operating cost is only 14,000, and the equipment if sold at the end of year 6, it will fetch you rupees 20,000. Interest rate is given to be 12%, and you have to tell me whether it is okay to continue with the Defender or whether it is advisable to switch to Challenger. Same process you follow again. You plot the cash flow diagram for Defender, you plot the cash flow diagram for Challenger. Now, in the analysis, please do not take sunk cost into consideration. What would be the sunk cost in this example? You purchase the equipment for 200,000 and now its market value is only 120,000. So, your sunk cost is 200,000 minus 120,000, that is 80,000. So, you have to forget about this particular value 80,000, rather you have to concentrate only on the current market price of the equipment which you are using right now. So, can you draw the cash flow diagrams corresponding to both the Defender as well as for Challenger? Once you are able to draw it, it becomes very simple to proceed from there. So, I have drawn the cash flow diagram for you. You can just cross check it. It is shown in the slide. Here Defender is the existing equipment and Challenger is the new equipment. For Defender, if you see, you purchased it for 200,000 2 years ago. So, at -2 you bought it at 200,000, and every year it is costing you 25,000 rupees as part of operating and maintenance cost. At the end of year 6 from now, you are likely to get rupees 25,000 as salvage value. Now, the current market value of this particular equipment is 120,000. That means, for a third party, as far as Defender is concerned, it is available at 120,000. In replacement analysis, you will find that sometimes some suppliers, they tell you, okay, I buy back this particular piece of equipment and I supply you your new one. So, whatever price he is offering you, that you can take it as a market value or market price, and that is what you have to consider for your analysis purpose, and not the price at which the equipment was bought originally. It would be unfair for the Challenger. So, looking at this cash flow diagram, it is very simple to calculate the equivalent annual cost. It would be 120,000, which is the market price at time t is equal to 0, multiplied by A given P, because I want to convert this into annualized value. So, present worth is known, I want to convert to its equivalent annual cost. So, I will use the factor A given P at an interest rate of 12% for a period 6, plus 25,000, which is the operating cost, and minus salvage values annualized value. So, salvage value is 20,000, I multiply it with A given F at an interest rate of 12% for a period 6. So, factor values are also given. A given P 12% at 6 for a period 6 is 0.2432 and A given F 12% for a period 6 is 0.1232. So, what I find is that equivalent annual cost is coming to be 51,104. That means, if I continue to use this Defender or the existing equipment, my cost liability on an annual basis is rupees 51,104. Clear? Now, I will go to Challenger. I will draw its cash flow diagram, which will be something like this. 150,000 is its acquisition cost at time t is equal to 0. Every year I have to incur 14,000 towards operation and maintenance, and at the end of year 6 it is likely to be sold at rupees 20,000. So, salvage value is rupees 20,000. Now, once this cash flow diagram is known to me, I can immediately calculate the equivalent annual cost for this Challenger. This would be equal to 150,000 multiplied by A given P, 12% interest rate, 6 years period, plus 14,000 is my operation and maintenance cost. This is already in annualized form, minus whatever salvage value I am getting, which is 20,000 multiplied by A given F, because it is in future. So, I have used the factor A given F 12% year 6. There are many ways through which this equivalent annual cost can be worked out. This is one of the ways. There could be many ways. For example, in one set of calculation, you can bring this 20,000 at time t is equal to 0, and then from that present value you can annualize it. So, there are many ways. Whatever way you find it convenient, you can use that. You will get the same answer. So, if you calculate using these values, you will get a value of 48,016 rupees as the annual cost, whereas in case of Defender you were getting about 51,000. So, which one is better to go for? You find that it is better to switch to the Challenger, because in that case the annual cost would be substantially less. So, this is how we perform replacement analysis. These two examples were very simple in nature. Now, we will see some complicated examples in which we are given different types of information. For example, we may be starting with again one problem in which we are given the resale value of the asset or equipment at different time. In another example, I will give you what is the obsolescence cost, what is depreciation, what is the investment cost for acquiring new set of equipment every year, what is the loss in productivity every year. So, if you go on adding those variables, you will find that the problems become slightly complicated, but the idea remains same. We have to find out that particular time at which my cost implication is minimum. This will be more clear when we do one problem in which information on resale value of the equipment is given to us. So, you can note down this problem. This is slightly different from the problems that we have already solved. In this particular problem, it is said that a small electricity generating plant has been purchased for $20,000. the operating costs based on the annual average estimated hours of operation are $800 in the first year. That means, first year operation and maintenance cost is $800. During this time, manufacturer's warranties operate, because if you are buying some equipment, so for initial few months you will find that warranties operate, and during such period you will find that the operating cost is quite low. So, that is what is given for the first year, it is $800. Second year it is slightly more, it is $1200, and thereafter it is increasing by $300 every year. Now, in this problem, the resale value of the plant is given for different years. I will show you, it is in the next slide. The cost of capital is 15%. So, what are the informations that you have in this slide? The cost of electricity generating plant is $20,000. First year the operating cost is $800, second year $1200, and thereafter it is increasing by $300 every year. Resale value I will give you in next slide, and the interest rate that you can use it for this problem is 15%. Now, you can note down this resale value in different years. For example, if you want to sell your electricity generating plant at the end of year 1, you will be able to sell it at $18,000. At the end of year 2, if you want to sell, you will get $16,000. Year 3, if you are selling, you will get $15,000. Year 4, you will get $12,000. Year 5, you will be able to sell it at $8,000. Year 6, you will be able to sell it for $5,000, and year 7, if you want to sell, you will be able to sell it at $2,000. Now, given all such information, we have to identify when is it most appropriate to replace this electricity generating plant. Now, here you will find that we are not having two separate set of information, one for defender, another for challenger. So, this is a different class of problem in which the replacement decision has to be taken based on the total cost of operating a plant or operating an equipment. So, what we will do, every year we will work out the cost, total cost for maintaining this particular plant, and this calculations could be can be performed for a number of years. You will find that initially the total cost comes down, and then we reach a point at which the total cost is the minimum, and thereafter the total costs go on increasing. So, we have to identify that particular point at which the total cost is minimum. Beyond that, if you want to keep that equipment or keep that asset, it would be uneconomical to keep that. So, that is the ideal time for replacement of that particular equipment. So, what we do? We have to perform this calculation year by year, right, at least for next 7 years, right. Every year we will see what is my total cost, and then I will plot a graph between period and total cost, and wherever my total cost is minimum, I will say that that is the time most appropriate time to replace the asset. So, we will try to work out this problem. So, for this we will follow a step by step process. What is given here is I have purchased the equipment for 20,000. So, in 20,000 I purchase the equipment, that means at time t is equal to 0 I have invested 20,000. Now, year 1 $800 is my operation cost, year 2 1200, year 3 1500, every year it is increasing by $300, year 4 1800, year 5 it would be 2100 and so on. This is year 1, 2, 3, 4, 5 and so on. Now, I have to work out the cost every year, total cost. So, suppose I take year 1. So, what are the total cost implication for year 1? 20,000 here, right, $800 here, this is 0, this is 1, and how much money I can get if I sell it in the market? $18,000. So, this should be sufficient for calculating the total cost implication for year 1. So, how do we calculate equivalent annual cost for year 1? Let us say it would be 20,000 A given P 15%. Now, period here would be 1 plus 800 minus 18,000. How much is this? This value is coming to be 1.15. How much is it coming? This would become 23,000 plus 800, 23,800 minus 18,000. Or else what I can do is, I can give you a tabular setup through which you can work it out. So, here I write year 0, 1, 2, 3, 4, 5, 6. Capital recovery factor I call CRF, which would be 1.15, 0.615, 0.437, 0.350, 0.298 and 0.264. This CRF is nothing but A given P at an interest rate of 15% and period N. Capital recovery factor is same as A given P at 15% for a given period N. So, if N is 1, it is equal to 1.15, if N is 2, it is equal to 0.615, if N is 3, it is 0.437, if N is 4, it is 0.350 and so on. For N is equal to 5, it is 0.298, for N is equal to 6, it is 0.264, right. Now, I can calculate equivalent annual cost of purchase price. This would be nothing but 20,000 multiplied by this value. So, here it would become 23,000. This would become 12,300. Sorry. This is 12,300. This would become 8,740. This would become 7,000. This would become 5,960. And this would become 5,280. So, what I have done? I have converted the purchase price of 20,000 into an annualized cost if the period is 1, if the period is 2, if the period is 3, if the period is 4, if the period is 5, if the period is 6. Now, coming to running cost. First year running cost is 800, 1200, 1500, 1800, 2100 and 2400. These values are given to me. Now, what I will do is I will bring it at time t is equal to 0. That means, I will calculate its present cost. What will be the present cost of $800 which I am incurring at the end of year 1. So, the factors are present cost factor I will give you. It is 0.869, 0.756, 0.657, 0.571, 0.497 and 0.432. These values I have taken corresponding to 15% interest rate and n is equal to 1, 2, 3, 4, 5, 6. This I can get it from the table. Now, what I have to do? I will multiply this 800 into this. So, if you call this column as D and if this is E, so I have to write D into E. So, 800 into 0.869 becomes 695, then this becomes 907, 985, 1027, 1043 and 1036. So, what I have done is I have converted the operating costs into its present cost. Now, what I will do? I will take the cumulative sum of present worth, this is sum of present worth of running cost. So, first year it is 695, second year it would be 1602. What I am doing is I am adding them up. So, this is cumulative sum of present cost. This becomes 2587, this becomes 3614, this becomes 4657 and finally, this becomes 5693. This I call it as F, which is D into E, this is G, let us call this as A, this let us say it is B and this is C. So, I have given the name for each of the columns B, C, D, E, F, G. F is nothing but D multiplied by E, and G is what? Cumulative sum of present worth of the running cost. Now, I will have to change to new set of paper. So, I will write year part once again, year 0, 1, 2, 3, 4, 5, 6, right. Now, I will make another column H. H is nothing but, you can note it down, equivalent annual cost of present worth of running cost. H is nothing but B into G. What I am doing? Present cost, now I am converting it into annualized value. This can be done in number of ways, but I am following this because it is easy to understand. First, I brought all the operating cost at time t is equal to 0, and now I am trying to annualize them. So, this will become for year 1 799.25, this will become 985.3, 1130.51, 1264.90, 1387.78, 1502.95. So, this is as far as the annualized value of present cost of present running cost is concerned. Now, we will add C plus H, and I call this as J. J is C plus H. So, add column C and H. C was giving me the annualized value of purchase cost. Now, this will be added into operating cost. So, this will become purchase cost plus operating cost. So, this will become 23,799.25, 13285.30, 9870.51, 8264.90, 7347.78 and 6782.95. So, this is nothing but addition of column C and H. So, this is the total cost as far as running and operation cost is concerned and purchase costs annualized value is concerned. Now, one more thing is left out, which is resale value. I call this as K. K is giving me the resale value. For year 1 it is 18,000, for year 2 it is 16,000, for year 3 it is 15,000, for year 4 it is 12,000, for year 5 it is 8,000, for year 6 it is 5,000. This data is given to me, resale value. I call this as column K. Now, in a similar manner, I will calculate the present worth of resale value, because the data which is given is at the end of year. So, now I want to bring it at time t is equal to 0. So, you can use the same present worth factor and multiply it. You will get a value of 15,642, 12096, 9855, 6852, 3976 and 2160. So, this is let us say column L and this is nothing but K into E. L is K into E. If you remember in column E you have written the factor values, right. So, what has been done in this column is converted, I converted resale value into its present worth. Now, finally, I write column M. In this column, I will try to annualize this present cost, because all my figures are getting converted into annualized value. So, this also I will convert it into its annual value. So, this will be basically M is L into B, and this value would be 17988 point something 7439 4306 2398 1184 and 570. Right. So, this is the equivalent annual cost for resale value alone. And now, finally, what we have to do is we will calculate the equivalent annual cost of purchasing cost, running cost and resale value. So, this is going to give me the total annual cost year by year. So, this is nothing but J minus M. So, column J minus column M you do, you will get the equivalent cost. So, year 1 it would be 5811, year 2 it is 5846, year 3 it is 5564, year 4 it is 5867, year 5 it is 6162, year 6 it is 6213. So, this is the total annual cost. That means, this is the combination of your purchasing cost, your running cost and your resale value cost. If you combine all of them together, you are getting the total cost liability for keeping that particular asset every year. For example, year 1 if you want to replace, your total cost liability is 5811, second year it is 5846, third year it is 5564. So, what you find here? The total cost is coming down. Initially it was high, but then it is coming down gradually. Year 2 it is slightly more, but then year 3 onwards it is less, then again in year 4 it has increased and then it is going on increasing. So, if you notice the last column, year 3 has got the total minimum cost, minimum total cost, that is equal to 5564. So, that is the ideal time to replace your equipment. That is the ideal time to replace your equipment, because if you continue to use that equipment beyond 3 years, your total cost implication is increasing. Is it clear, technology class? Okay. Now, I will give you a similar problem for your practice. You can note down this. the purchase price of an equipment is $7,500. You note it down. I will say whatever I am telling you, please note it down. The initial cost of an equipment is $7,500, right? Arithmetic gradient maintenance cost is $900. Arithmetic gradient maintenance cost is $900. That means your maintenance cost is increasing every year by $900 in an arithmetic manner. $500 is uniform cost. That means every year you are incurring $500 also, and $400 is an arithmetic gradient operating cost. Clear? I will repeat it once again. You have purchased the equipment for $7,500. Your maintenance cost is increasing every year by $900. Your operating cost is $500 every year, and this is increasing by $400 every year. What I will do, I will give you this in the form of a cash flow diagram so that it is more clear to you. So, if you just look at this, you have purchased the equipment for $7,500. Now, starting year 1, your maintenance cost is increasing every year by $900. So, this will be $1,800, this would be $2,700, this would be $3,600. This is year 2, 3 and 4. This is as far as maintenance cost is concerned. Now, you are also given the operating cost, which for year 1 was $500, and it is also increasing by 400 every year. So, 900 here, 1300 here, 1700 here. So, this is as far as operating cost is concerned. The top diagram is for operating cost, bottom diagram is for purchase cost as well as maintenance cost. Now, both these diagrams you club together, that is the cash flow diagram for the existing equipment. Now, based on this information, you have to tell me what is the ideal time to replace this equipment. Is the problem clear to you, technology class? You have purchased the equipment for $7,500. Please note down this slide. You have purchased the equipment for $7,500, that means at time t is equal to 0. This is your maintenance cost for year 1, $900. Next year it is $1,800. Next year it is $2,700. Next year it is $3,600. So, the gradient is $900, and for this problem only you have separate information on operating cost also. Operating cost for year 1 is $500, and thereafter it is increasing by $400 every year. Year 2, year 3, year 4, like this. Second year it is 900, third year it is 1300, fourth year it is 1700, and so on. Now, question is, at what point of time you should replace this particular equipment? Now, is it clear? Okay, so I will give you the answer for this, you can cross check it. See, this is if you see this particular slide, you will find that at the end of year 4, I will send you these values. I will send you this particular slide, do not worry about it. I just wanted to give you an answer that at the end of year 4, it is appropriate to change this particular equipment. And if you want to see the graph of it, it is looking something like this. See, the total equivalent annual cost is given in the first diagram. First figure, if you see, initially the cost is high, then it is coming down. At the end of year 4, it is the lowest, and then it is increasing afterwards. So, that is the most appropriate time to replace your equipment. So, this type of graph you can draw it on your own for this problem, and then see on your own what is the total cost, how the maintenance and repair cost is behaving, how the operating cost is behaving, and then finally how the total cost is behaving. So, these are the two set of problems we have discussed under replacement analysis. I will give you one more problem, you can note it down. Yes, you can note down this particular slide. I will read it out. A precast concrete company. Okay, what I will do is I will change the font and give you the revised one. What I will do is I have increased the font size, and now it is you can note it down. Yes, now you can note down this. A precast concrete company is considering purchasing a small concrete mixing plant to be used for on-site remedial work. So, basically a company is interested in buying a small concrete plant. The equipment suppliers claim that because of limited use, the resale value will remain high and the equipment will operate efficiently for 20 years or more. Resale value would be high and equipment will last for more than 20 years. Right. So, what information you have in this slide? A company wants to purchase a concrete mixing plant, and the manufacturer has informed him that the equipment will last for more than 20 years. Is it clear? Okay, now move to next slide. The precast company has asked you to assess the replacement age, assuming that there will be a continuous demand and that when the equipment is retired, replacement will be made by similar piece of equipment capable of the same performance. The initial cost of the equipment is $15,000. So, that means the concrete mixing plant you can buy it at $15,000, and whenever you find it appropriate for replacement, you can get a new set of equipment. Please note down this. Right. Now, the last point of the problem, the operating cost of the plant is $500 in the first year when the manufacturer's warranties operate, and $1,000 in the second year, increasing by $300 per year thereafter. The resale value is determined to decrease by 12.5% per annum compounded. The cost of capital is 12%. So, this is very similar to the problem that we have solved just now. Only thing, the resale value you have to calculate based on the percentage that is given. So, every year you reduce it by 12.5%. So, first year 15,000, next year it would be 15,000 less 12%, 12.5% of 15,000, and like this you calculate the resale value, and you are given the operating cost in the first year as $500, second year $1,000, and every year an increase of $300. So, based on this information, you can perform similar calculation as was shown in the previous problem, and then tell me what will be the ideal replacement time for this particular piece of equipment. So, with this, I will just like to summarize whatever we have discussed in this particular class. We have primarily discussed replacement analysis problems in this particular lecture. There we defined what is defender, what is challenger, why at all we replace a particular equipment or a particular asset, and how to perform the analysis. We have taken two types of problems, one in which we have information on defender as well as challenger both, and then in next set of problem we have no information on challenger, but we are required to find the most optimal time for replacement of a particular existing asset. So, in case when defender and challengers information is given, I have taken out the cash flow diagram for defender separately, challenger separately, and while analyzing this type of problem, I have adopted a third party perspective in which I have not considered the sunk cost, right. So, this is one thing that you have to remember, that while considering defender, it is the market value of the defender at time t is equal to 0 which needs to be considered. And in second set of problem, we have calculated the annual cost every year, and whichever year gives me the lowest value, that is the ideal time for replacement of that particular asset. So, with this I conclude this particular lecture, and if you have got any doubt or query, you can ask me now. Thank you.
Hello?
Yes?
I have one question based upon the exercise 3. I mean example 3.
Example 3,
Yeah.
which we did it here.
With different receipt values.
Okay, this one.
Yeah.
Okay, tell me what is your doubt?
We have receipt values up to the 7 year.
That we didn't use because I could find out the trend. You found that.
Why not 3?
Why not 6?
No, why not 3?
What is telling? Why not? See, what you find that it is of no use to consider for year 7 because the cost is increasing from year 3 itself. If you want, you can perform the analysis for year 7 also.
Okay.
But since I can understand the trend that from year 3 onwards the cost is increasing, I have not gone beyond year 6, but you can go for it, there is no problem.
Okay.
Any other doubt you have?
Yeah.
Please tell me.
Would you please tell us the interest rate of exercise 2?
Exercise 2, it was 12%, I think, 12%.
Arithmetic gradient.
Okay, arithmetic gradient, I will give you the interest rate, 8%. I will give you. Interest rate is 8% you can take.
Okay, thank you.
Okay, any other doubt? Thank you and good night. Which one? Old? नहीं actually नहीं मिल, I have not done it. ठीक है, maybe tomorrow I will be able to give. ठीक है, because